This presentation will outline glomerular filtration rate. Glomerular filtration is the process by which blood plasma and small dissolved molecules pass out of the blood and into the glomerular capsule. The green arrow shows where the blood plasma and dissolved substances leave the blood and enter the glomerular capsule. The glomerular filtration rate is the amount of filtrate in all renal cells each minute. In males, it's about 125 milliliters per minute, and in females, 105. The glomerular filtration rate plays an integral role in maintaining homeostasis of bodily fluids. Blood pressure fluctuates in the body due to a variety of stresses such as exercise, so regulating GFR is important in order to overcome the body's natural fluctuations in blood pressure. An unregulated GFR can cause problems. When GFR is too high, there is less time for reabsorption, and so useful substances to the body may not get reabsorbed and will be excreted in the urine. When it's too low, there's too much time for reabsorption, so the body's waste products may not get adequately excreted and instead will be reabsorbed into the body. Measuring the GFR is a good indicator of overall kidney function. Controlling blood pressure in the glomerulus controls glomerular filtration rate, and more specifically this involves regulating the vasoconstriction and dilation of the afferent and efferent arterioles. This picture depicts the afferent and efferent arterioles. Vasodilation and constrictions of these will change the pressure at the glomerulus and in turn regulate GFR. These are the three factors that affect GFR: autoregulation, hormonal regulation, and neural regulation. So starting with autoregulation, the two mechanisms here are intrinsic, as the kidneys are acting upon themselves. The myogenic mechanism involves smooth muscles of the afferent arterioles. An increase in blood pressure will increase the stretch of the arterial blood vessel walls, causing smooth muscle of the afferent arteriole to constrict, narrowing the lumen and decreasing renal blood flow and therefore decreasing GFR. And the opposite will happen when there's a decrease in blood pressure. Tubular glomerular feedback is a negative feedback loop, so any increase in GFR reduces the time for reabsorption of sodium, chlorine and water. The macular denser cells in the renal tubules detect these increased levels, therefore decreasing the release of nitric oxide, which is responsible for vasodilation. A reduction of nitric oxide causes the afferent arteriole to constrict, decreasing blood flow and GFR, and again the opposite will happen with a low blood pressure. Here you can see the macular denser cells highlighted in yellow. Hormonal regulation involves two extrinsic mechanisms, angiotensin II and atrial natriuretic peptide. Angiotensin II responds to reduced blood pressure, as this reduces the stretch of granular cells surrounding the arterioles, and this causes the secretion of renin. The secretion of renin activates angiotensin II, which constricts the lumen of both the afferent and efferent arterioles, causing an overall reduced blood flow and reduced GFR. Here you can see the granular renin-containing cells. Atrial natriuretic peptide is secreted when there is an increase in BP, and this causes an increase in stretch of the heart's atria. Its secretion relaxes the mesangial cells in the juxtaglomerular apparatus, which increases the surface area of filtration. Here you can see the mesangial cells, shown highlighted in yellow. Neural regulation involves the sympathetic nervous system, also called our fight or flight system. The sympathetic nerve fibers that innervate the kidney work to reduce GFR in order to reduce urine output, which is not of primary concern during fight or flight. It also conserves blood volume, which may be important in times of hemorrhage, and it also redirects blood flow to other areas that are more important, like the skeletal muscles. At rest, there is minimal sympathetic nervous system stimulation, but under stress, the sympathetic nervous system is stimulated and secretion of norepinephrine occurs. This constricts the afferent arteriole, reducing blood flow and GFR. This response will override local controls and may come at the cost of acute renal failure. So to conclude, glomerular filtration rate is the amount of filtrate in renal cells every minute, and it's important to regulate in order to maintain homeostasis of bodily fluids, as if unregulated can lead to the over-reabsorption or under-reabsorption of bodily compounds. So in conclusion, intrinsic and extrinsic regulators work together to maintain this relatively constant GFR.